Hello all. Today we are solving LeetCode problem number 3721, longest balance separate part 2. So yesterday we have solved part 1, which is very easy compared to this problem because this is a very hard problem in fact. So we use advanced concepts like segmented tree with lazy propagation and prefix sum to solve this particular problem. So let us understand this problem step by step. So before getting into the solution, let us read through the problem and understand once again what exactly is needed from this uh, problem. So you are given an integer array called nums, and the subarray definition is given. A subarray is called balanced if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers. So you have to return the length of longest balanced subarray. So in the example one, it is given that we have 2 5 4 3. So odd is 5 and 3, which is nothing but 2. Two values is there, and even is also 2 and 4, so two values. So distinct odd equals to distinct even. So hence we can return the length which covers all these four elements contiguously, right? So which starts from index position 0 till index position 3, right? So which is of length 4, which is nothing but it will be uh, 0 plus 3 plus 1, so this is the length. So hence this will be 4, so that is what we are returning as a solution, answer. So yeah, so first thing is, before jumping into the proper solution, let us understand the constraint. So we cannot solve this problem by big O of n square as we solved the first part, because the constraint, it is given that the number lies between the length in 1 to 10 power 5. So if we are using 10 power big O of n square, this will result in a time limit exceeded issue, TLE issue. So due to that, we cannot go up with that particular approach. So we have to find some better solution, which is of big O of n log n solution, so that we could solve this problem, right? So first thing first is, we will convert this, or we will represent this problem mathematically, because last time we used a set to track down the odd and even numbers in the previous problem. But for this, let us use the mathematical representation for this. So instead of thinking the subarrays directly and things, we can think in terms of prefix difference. So the prefix difference is nothing but it is the difference of the odd numbers minus, or yeah, this odd number should range from uh, any index up to I, and this should be subtracted by difference of even numbers up to I. So you will have a range. For example, the range may be 0 to I. So in the 0 to I, if the difference of odd number is minus the difference of even number, will be a value, and that will be the prefix difference. So now you may wonder why we are getting into the prefix difference, right? So because a subarray is balanced if and only if the number of distinct even numbers is equal to distinct odd, right? So using that only, we will be calculating the longest subarray. So that can be represented mathematically by using this prefix only, because when you take a complete array, you have the range from 0 to n minus 1. So you find within that range, and you find the number of number of even and number of odd. So using that you can come up with the prefix value. So you, because that will be the prefix value for prefix difference value for n minus 1, right? N minus 1. So in terms of prefix, even that can be uh, a value, and using which you can you can have a observation, because that will be the prefix value for n minus 1, and you can find the other prefix differences for separate index value as well. So for example, prefix difference for 0 also you can calculate. So if this prefix value 1 and this prefix value 2, if both are equal, right, when these two prefix difference values are equal, you can say that this will be this will form a balanced subarray, right? So which is nothing but the n, this is n minus 1, right? So n minus 1 plus 1 till 0 forms the length of subarray. This gives the length of subarray which is balanced. So this is the first mathematical observation we need. So let us run a dry run, for example, or let us run through an example for our understanding. So we can have nums equal to 2, 5 and 4, 3, right? So we will have we will track the index, right? So we'll track the index here, and we will have value and the prefix. So this will be the start, the 0 will be the start, right? So we will not have any value, and the prefix will be 0, right? So for 1 and 2 and 3 and 4, right? So for all these value we will track. So this starts with 2, the value is 2, and we will have even as -1, odd as +1. So this is even, so this prefix value becomes -1. So number 2, at 2 we have a 5, right? So we have 5 here, which is odd, so you add it, you get 0 here, right? So now the next one is 4 and next one is 3. So this is even, this will be -1, and this is odd, this will be 0. So this is 0, right? So now you can see that prefix of 0 is equal to 0, and prefix of 4 is also 0, and also you can note that prefix of 2 is also 0. So what will be the balanced range? Balanced range will be from 0 to 2 and 0 to 4. So which will be the highest, the balanced subarray with highest length? The 0 to 4, right? So here you can have one more observation. The leftmost value, right, which prefix of I is equal to prefix of current. So for this value, for which leftmost value this condition satisfies, we have to pick up that, and that will be the length. So which is nothing but the let this be we can have it as current plus 1 till I will be the range, using which you can calculate the length, right? So now we know what is the basic idea for this, and now we may wonder why this problem is so hard. It's kind of easy, right? Why is it hard? Because the main hard part comes because of a particular condition of this problem, which is nothing but you will have duplicate values. So which means there is distinct numbers there, but you will have a chance for duplicate values as well. So for example, you may have, if in an example you may have twice, right? So in that case, what you have to do is to track this. You have to because when 2 appears, you will have the index for this, right, tracking. So the index value will be tracked for the complete array. So if the next two appear, what you have to do is you have to again update the index, right? So this is a tedious problem. This is the what to say, this one is one required, and again you will you should not update the +1 and +2, I mean -1 value, because this is even, so you will not add one more -1 value as well, but you have to track the index. So you have two cases, that is plus not two cases exactly. You will have first I will write down the first cases, which is nothing but you have to +1 or -1 tracking, right? And the second one will be you have to update the index, right? And again you have to, this forms a new segment, and you you should find the prefix where the prefix of the I equal to prefix of current, right? So these three things you have to find. So for tracking this, you cannot use hash map, right? Why? Because the values changes dynamically. So this is the place where we use segment tree and lazy propagation along with the same prefix sum calculation to track down the index values, right? So using that, you can easily perform this operation, right? Uh, the adding, that is removal and add of a new contribution with updated index, you can add it, right? So because of that, the things becomes very easy, right? So you have the operations. This could be done by big O of log n. So this could be done by log n, the removal and adding. So hence, because of that, you can use segmented tree. So now I have already written down the steps for making things easier. uh, so the segmented tree and lazy propagation solution. So you will have main three arrays to track down or to build the segmented trees, in fact. So I will show how we build the segmented tree nodes. So we have this minimum array which will store all the nodes. um, uh, we will be accessing them by the index, because since it is an array. So we also have maximum, so this stores the minimum prefix value in that particular segment. So you may have the -1, and if it is 3 or 3 odds, sorry, 3 evens, you will have 3 negative as a number, right? So because of that, this will be to track down this minimum prefix value, you will use a uh, minimum array, and similarly to track the maximum value, you will have maximum array as well. So, and this is to a lazy addition to play, right? So this is a special array which we will be used to calculate the lazy addition. So using that, we will be dynamically updating the the values with it, so which will be helpful while calculating the prefix value. So we will see where these all three coming in a place for the segmented, for calculating the longest value. So these three character, not exactly characters, so these three uh, parameters will be at each node of a segmented tree. So all these values will be for each node, you will have a different value stored here. So the contribution decision will be, for odd you will have +1, and for even you will have -1. So the next thing is you have to track the number, and if you have to track down if it is appeared before or not, so you will have use one more array to track down all the values. So if the value appeared again, you will have a track of it. So if the value appeared again, as I said, the 2 right? So if it value appeared again, so you will remove the contribution first and you will add. So which means for removing, what you have to do is the old index and the minus x value. So whatever node is given, you have to remove that, right? So you will add the old index and then minus x node value, so which will remove it. And the next step, you will add the new contribution using the current index and the node value, the whatever value. It's not exactly to understand this, you can have it as the array of a particular index value, the current index values in the array, right? So now to find the longest balance subarray, the idea is to find the leftmost j such that prefix of j is equal to prefix of current. So this is what exactly we have seen there. So we will build the tree using all these values. So if we, for example, if we are pushing a first index value into the tree, we will calculate the minimum value when the index is there, that is from the range 0 till I. So for example, first index it will be 0, so 0 to 0, this will be the minimum value will be calculated and maximum value will be calculated, and then the tag also will be calculated, and then it will be pushed into the tree. So this is how you form the tree. And how to find if there exists the balance subtree. So this is the very important condition. So this is the place where the mn and mx comes into play. So minimum value and maximum value comes into play. So when you consider a segment which is I to j as a segment, you will have the minimum value in this index, right? So also you will have maximum value stored in the array of the in which you can access through the same index. And this current prefix, how do you calculate current prefix? So that is the reason why you have the tag value, right? And also you will have accumulated sum value which will be calculating using the d variable. So you will calculate the accumulated sum and the current accumulated sum at the particular same index as well, index and the current accumulated sum at index, that is d at index minus this tag at index. So this will be the current prefix sum. So if the value formed is within this range, so then definitely you can say there exists a balanced subarray, right? So this is the main condition which we have to test. So now I will show the dry run for this particular problem. So we will run through the for example completely based on the solution or the code whichever I have written. So here, to make the code simpler and easier, not easier, just to reduce many number of lines, because segmented tree, this operation will when we write it down as a code, building the tree, that will take so much of lines of code, so which will consume more time. So that is the reason why I have decided to go with the bit manipulation techniques for making things easier. It is very little hard to understand, but we will understand by having a dry run. So this is the basic idea for this. So the only thing is we have to understand how we are building the tree and how we are doing this add operation when the new number comes, and how we are doing this add operations when the old is there, and how we are finding the left most the longest balance subarray. So you have to find the index, right? So if this condition exists, so there is an index which will satisfy the balanced condition. So that is what we have to return. So how are we making use of segmented tree and coming up with solution, right? For the dry run, let me write down the example. So we have the same example, which is 2543. So nums equal to 2543. Then we will write down all the arrays, right? tg and minimum, that is tag maximum. Then we have add function, which will accept the index and values as input, right? So this is a function, and again query function. So this will return the j index for which the condition prefix condition satisfies, right? So let us start the try run. So we have n is equal to 4, the size of the array. So first thing first is we have to create the number of nodes, so which will be which should fit in all the values right within the array. So because of that, we will have n is equal to 4, and we will use a bit length operator to calculate all the trailing zeros, so using which we will perform the left shift operators, and we will calculate the nodes. So let m be nodes in tree, right? So m is equal to 1 left shift by n dot bit length. So for example, this case we have n is equal to 4 1 2, so this should be 1. Oh, okay, 1, yeah. Oh, this should be 100, right? So this is a binary representation of 4. So trailing zeros is 2 here. So using this left shift operator, so this will result in the values to be 1000, right? Yes. So this will be 8. This should result in 8. So m will be 8, and the number of nodes to construct a tree will be tree is equal to 2 cross m, which is nothing but 16. So what we will do is we will map leaf to the to 8 from we will map the leaf to index, the values in array nums from 18 till the 16, which is nothing but it starts from 0 to 15, right? So because of that, this will be 8 to 15. So this range you will map all the values, so you will have every index in the tree node. So for example, 1 will be in 9, and sorry, this 1 will be in 9, yes, 0 will be in 8. So 2 3 and 4, so this will be in 10 11 and 12. So this is how it will be represented, and the arrays will be, the tag will be from 0 till 15, again of the size m, right? So and minimum n also will be from 0 to 15, sorry, everything initialized with 0, and max also 0 to 15 initialized with 0, and last will be a map to track. In fact, we can have that as array as well, but for explanation purpose I'm having it as a map, right? So or set, whatever. So answer equal to 0, right? So initially prefix everywhere will be 0, right? So we start the first iteration. So we have I is equal to 1 and the value is equal to 2. So since it is even, and hence this value will be -1, right? So since it is -1, the x value will be -1, right? So you have to check. This is the step 1. So step 2, you have to check if removal is possible. So how can we do that? Check in by in the last of 2. If it is some value is there, right? If it is not equal to 0, then there is some value is there. So not equal to 0, there should be some value is there. So in that case you have to remove. So if it is equal to 0, there is no need to remove, since it is the first index, right? So there is no last of 0 is equal to 0. This should not be 0, this should be 2, the value, right? So this should be 2. 2 is equal to 0, so no removal. So now what we do next is we add the values, which is nothing but -1, and the index is 1. So this is what we add. So next what happens is when we add the values into the trees, right? So when we update the tree node, we will be using now I will explicitly add 1 and -1. So what happens here is you add with m, so m plus the 1, which is nothing but you use or operator here, which is I or with m is equal to 1 or with 8, which is nothing but 9. So at node 9 this value will be added. So as I said, this will be the leaf node, right? So due to it is being a leaf node, you add the values here. So now we have to update all the arrays. So tg of 9 -1, the value is v here, right? So change the ink, so sorry, and minimum of 9 plus or equal to -1, and maximum of 9 plus or equal to -1, right? So now everything of 9 will be is equal to -1. So the values at node 9, the leaf node 9, which represents the first index, is updated to -1. So now update parents. So now 9th parents will be this will be 4, right? So 4 will be having 2 branches, which will go to the 6, 7 and 8, 9. So 4 will the parents of 4 will be I think this should be 2, right? So yeah, so this should be 2. Parents of 4 will be 2, and because 2 from 2 it goes to 3 and 4, yeah, it will be 2, and from 2 it will be the root node, right? Yeah, so it's because of that. Now you have to update the node 4, which is nothing but this. So the children will be 8 and 9, which will be moving to 4, right? And yeah, so it's because of that there is no value but 8. So now the value but 8 will be, sorry, let me change the color. So this value will be 0, but here the value will be -1. So now minimum mn of 4 is updated to minimum of -1 and 1, which is nothing but -1, and maximum of 4 is equal to maximum of 0 and 1 is nothing but 0. So now this is, since it's been updated, you next move to node 2. So at 2 the children are 4 and 5, right? So so it's because of that you will have minimum of 2. The 5 there is no value, so it will be 0, and here 4 it will be what value will be at 4? It will be -1. Yeah, so the minimum will be the minimum of this, right? The -1 is here, so minimum of 2 will be -1 and maximum of 2 will be 0. And next one is the root, so which is nothing but the root child will be 3 and 4, right? So since, sorry, 3 and 2, in fact this should be the opposite one, yeah, 2 and 3, right? So hence because of that minimum of 1 will be again -1 and maximum of 1 again will be 0. So this is the root value. So now you have updated the tree continuously, so this operation cost is less, so dynamic updation is happening here, right? So now the current representation of the prefix, so you have updated the tree, again you will have updated the prefix array as well. So the current prefix will be for index 1 2 3 4, it will be -1 0 0 0, right? So now tree is ready and prefix array is ready. So the current prefix value is -1. So now your task is to find the leftmost -1 in the tree. So that is where you use this query function, which will return the j index value, which will have the leftmost -1. So why it is returning the leftmost value? Just to find the maximum value, the maximum distance or maximum size of the array, right? So now for finding this, we start from the node 1. So node 1, right, we want to check if the range here is from -1 to 0, positive to negative, minimum value to maximum value, -1 to 0. So -1 is here, so um, this we find -1 to be here. So now we have to go leftmost, so which is 2. We have to check if -1 exists here. Again this range is -1 to, sorry, -1 to 0. So here I will have it as yes and again yes. So since it is yes, we will again move to leftmost, so which is nothing but 4, right, is 5 anyway, so this is 4. So -1 to 0, so again this will be yes. So now we move to leftmost, which is nothing but the next value will be 8, right? Yes, this value will be 8, the node left will be 8, but here the value is 0 to 0, right? So it is no. So next what we do is we backtrack, we move to node number 9, right? So where the range here is -1 to 0, so here it is yes, right? So again we move left, no, and we move right, no. So 9 is the leftmost value where prefix condition satisfy. So now what we do is we do XOR operation with 9 XOR m, which is nothing but 1. So this j will be equal to 1, right? So coming to this prefix array which we formed here, so I is equal to 1, j is equal to 1. So now the the size, right? So that will be we have to find the maximum. So max val equal to max of existing answer minus this query function minus 1, so which is nothing but 1 minus 1 is equal to 0. So this is the first iteration. So we repeat the same thing for each and every element. So when we move to the next one, where is the array? A bit confusing here. Yeah, where is the array? Prefix array. Yeah, here it is. So when we move to the next index, we have phase even. So what happens is prefix summit gets updated to 0 here. So we repeat the same thing, and finally we will be getting this length as 4. So same thing we have to repeat it, and we will be returning this answer. So the coding part with using this bit manipulation techniques will be a little bit confusing, but yeah, so this is the better solution for this problem, as this is a very hard problem to solve. The time complexity will be big of, sorry, oops, so the time complexity will be big of n log n. And yeah, so with this, let us go ahead and code this up. For the solution of this problem, for defining the segment tree, we will be using this bitwise operation to make the solution a bit more memory efficient. So first we have to calculate the length. N is equal to len of nums, and then we have to calculate the bit length, using which we will be doing the left shift to calculate the number of nodes which is required. So we will use m is equal to 1 left shift by n dot bit length function. So what happens here is, if the length say if it is 3, which is nothing but which will be equal to 1 left shift 3, which is nothing but 8, so we will create 8 nodes. So in this way we can make the memory of the nodes to be created much more efficient compared to defining 4 times the node, right? So yeah, so now we have to create all those the helper arrays. So first we will start with the last, which will track the index where the value which the value in the nums lastly appeared, right? So last is equal to 0 cross this will be max of nums plus 1, right? And now we will have maximum and minimum. So I will have mn for minimum and mx for maximum. So this will be nothing but again 0 multiplied by the same 1 sorry, this time this will be m left shift by 1, right? Yeah, so this is to calculate m, and now m left shift by 1, so this will be the value for initially we are having the minimum values, right? So similarly we will have the same for maximum values as well. So the next one is we have to have the lazy propagation tag, so we will have next array for that as well. So is equal to the same value, right? So now we have to declare the answer, which is nothing but initialize answer, not declare, initialize answer, I'm sorry for that. Yeah, so now the thing is we have to enumerate the for loop. So this answer is nothing but we will have the final count and we will return, right? So now we have to enumerate the for loop, but before moving into this we have to define function. So let me just define function def add and define query. So these two functions we will be return using it. So we will return write the logic later. So just for defining so that we can reuse the same thing while processing by enumerating the for loop, the nums, right? So for I and value in enumerate of nums and 1, right? So now we have to have x is equal to 1 if just this is to find odd number or the create this is to find the odd or even. So if it is a 1 it is odd, and if it is even it is -1, right? So x is equal to 1 if it is odd. So how do we find it? Value and 1, right? Is if it is true this will be odd, and else this will be -1. The x value will be -1, so that we can track the odd or even. So using which we can transform the array into balance array, right? So now we have to do is the next step is you have to check the last value, and if it is there you have to remove the old contribution. Sorry, this is the next step should be you have to check the duplicate value. So if the duplicate value exists and already it's been contributed, you can remove the old contribution and freshly you can add a new contribution here, right? So this can be done by if pi is equal to last of value v, right? So if in this condition you have to add -x, so the same add function where you will pass in the pi, and this will be you will remove the old contribution by -x, right? So and now you will add the new contribution. So let me put it. So now you will add, so add I, and this will be x, right? So and again you have to update the last. So last of v is equal to I, just to make sure the last occurrence of that particular values, right? So now answer will be equal to maximum of answer, and here you will have I minus query, right? So now the next thing is you will go ahead and return ans, right? So now we will go to this we will add the logic for this add, right? This takes two parameters, which is nothing but I and v, right? And now before writing this we have to define one more function which will calculate the number of trailing zeros. So this should be count, right? So which will accept x as the parameters or the many values, as we will be anyway passing here x to calculate the number of trailing zeros. So I will come y we are finding out the number of trailing zeros. So now we will return this should be x and with -x. So dot bit dot length -1. So this is the logic to find the number of trailing zeros for the bit value whichever is being provided. So for adding this, the first step is we have to calculate, or we have to move to tree node. So for that we will add m plus I to move to or to navigate to the tree node. So since this add value this function adds v to all prefix sum of the index I to end. For doing that we will be calculating the tree node first. So to do that, x is equal to I or with m, so which is nothing but example. If we have better, I will write the next part line, the line of code, and then come up with the example, because this part is nothing but this is a kind of a crazy logic, which definitely even I cannot even understand until I saw an example. So this part, what it is doing is it jumps to by this line, the value, it jumps to the next segmentary node that covers a suffix range from the current leaf, right? So how do this do? It jumps up and sideways within the segmentary layout which is being provided. So I will write the code, the logic, which is nothing but x is equal to, there should be left shift of sorry, this is right shift of x by the trailing zeros. So where we pass in x as the value, and this should be subtracted by 1. So the example here is, we will have, for example, let me write it down better. Yeah, better, I will write it down here. M is equal to 8, for example, and I is equal to IB3. Then what the x value is? X value is equal to I plus m, or in terms of bitwise addition, it should be an OR operation. This will result in 11, right? And now the binary of this is here, x will be equal to 1011, right? And now the trailing zeros for this 11 will be, since it is 1011, there is no trailing zeros, so is equal to 0, right? So these are the required ones. So now we will compute this equation. So for x right shift of 0, so x right shift of 0 is equal to this will be 11, right? A right shift of 0, there is nothing to shift, so this will be 11, and 11 minus 1, because of this equation 11 minus 1 is equal to 10, right? So now x will be equal to the initial value of x is nothing but 11, right? So 11 minus 10 is nothing but 1, which is nothing but the root. So this is how it navigates, right? So navigate within the tree. So the next thing is we have to find these functions. So now it should be, in fact this should run within a loop actually. So while x, right? So we do this, oops, right? And now we will be marking the tags. So tag of x plus or equal to by v, right? And this is why we run this loop, right? So until the x value is true. So now x will be is equal to I plus, again we have to update back to the same value. This should be I, this should not be 1. So I, or I added with m, right? And now again while x, so now again we do the right shift by 1. So we run this while loop until x becomes 0. So x right shift are equal to by 1. So now we have to find the maximum and minimum value, right? So max of x is equal to, this should be max mx, and mn of x should be equal to, so here this should be max of max of x left shift by 1, and this should be added with tag of again x left shift by 1, comma max of x left shift by 1, and this should be added with 1, right? Then followed by tag of x left shift by 1 plus plus 1, right? So yeah, so now where I will again copy this and paste it, and this should be the same for the minimum as well. Only thing is we have to find the minimum value. So other than that, every the comparison remains same, so there should be minimum. And now yeah, so that is good to go, right? To add, now the idea is to define this query. So for query, this should accept no function, in fact, because the idea for this is to return find the first position where the prefix sum becomes invalid, and basically it is searching the answer using the binary segment tree, right? So first we will start in root node, and we will define the accumulated sum to be 0. So this will be starting with x as 0, and the accumulated sum will be, so this should start with root, right? So root means this should start with 1, and the accumulated sum is 0, and while x is lesser than m, right? So we start from root till all the nodes go down the tree, right? Until we reach the leaf nodes, we go down the tree and we add the lazy tag value into the accumulated sum. Then what we do is we go left child, because in the left only we can find the 0 value, right? So if it is 0, we can say that it is completely balanced, and we can find the length of the subarray which is being formed, right? So in the leftmost it exists the value, so because of that we traverse the the left node, left child, in fact. So that is the idea for this function, right? So now it will be accumulated sum. This should be tag of x, right? And shift by 1, left shift by 1, and if not minimum of x is less than or equal to, this is minimum mn less than or equal to d minus tag of x, and less than or equal to, there should be maximum of x, right? So in this case you increment the x by 1, so this will be x equal to 1, and you will repeat the same, and you will find the x eventually, and you will return x power m, right? X power m. So by this we will convert the binary nodes into the array index. So due to that, you can go ahead and return I minus the index, or whichever index which we get out of the query, right? And we can go ahead and return this. So let us run this. Okay, there is more typo here. So length and gth, and let me check again. So this is minimum, so this should be minimum as well. It should not be maximum. tag is fine. This should be minimum, and this should be left shift by 1 at each iteration. So this should be this, and let us run once again. Length. Okay, so now it's fine. Let me submit this. And there you go. Thank you.